In this video, I'm going to show you how to verify trig identities involving double angle identities. Verifying a trig identity means picking one side of the equation, and we're going to rewrite it with equivalent forms until it looks like the other side. In general, you want to pick the more complex side, and that will almost always be the side that has the double angle in it. So I'm going to pick the left side of the equation, and I'm going to rewrite it, and hopefully I can figure out how to make it look like the right-hand side of the equation. I'm going to start by substituting for the double angle. These are my double angle identities. The tricky thing about cosine is that there are three different cosine formulas, and I have to be careful about which one I'm going to choose. I have not worked this problem out yet, so I'm going to just figure this out right in front of you right now. But here's my thought process. I'm looking at the other side of the equation. I see a cosine sitting there, and then I'm looking in the numerator, secant. Secant is the reciprocal of cosine. So the right-hand side of the equation seems to be all about cosine. That makes me want to pick the version of the cosine double angle that only involves cosine. So I'm going to try that substitution and see what happens. So cosine of 2x equals 2 cosine squared minus 1. All right, let's go with that and see what happens. So I'm going to have, all right, I've got my 2 in the numerator, and I've got my 1 plus, here comes the substitution I just mentioned. 2 cosine squared minus 1. All right, 2 cosine squared x minus 1. It is very important when you verify an identity, pick one side of the equation and stick to it. It's very tempting to come over here on the right-hand side and go, okay, in the denominator I have cosine, and then secant is 1 over cosine. So it's tempting to come over here and start manipulating this, and maybe you'll notice that this is the same thing as 1 over cosine squared. But you can't do any of this. You cannot change the other side of the equation at all. So we need to just stick with the left-hand side until it looks like the right-hand side. I'm noticing that we have like terms right now. I have this 1, and then I have this negative 1. Those will actually cancel each other out. So that's going to leave me with 2 over 2 cosine squared x. These 2's would cancel each other out. That will leave me with 1 over cosine squared x. Okay, I'm seeing that I want a cosine in the denominator. And here I have 2 cosines in the denominator. So I'm going to split this apart. Okay, 1 over cosine squared, that would be the same thing as 1 over cosine x times 1 over cosine x. All right, I'm splitting that apart so that I can have, see, there's my cosine in the denominator. That's what I wanted. But I also want secant, don't I? Well, I'm in luck because 1 over cosine, that is secant. So it doesn't really matter which one of these I change. Maybe I'll change this one. So 1 over cosine is the same thing as secant. So I really have secant times 1 over cosine. Okay? And it wouldn't hurt if I called this secant over 1. And of course, if I multiply these together, that gives me secant x over cosine x, which is the target. So in the end, I will just write secant x over cosine x, and now I will finally bring down the right-hand side to show that they are equal. So we verified that identity. Let's do it again. Okay, this one involves all kinds of double angle identities. Actually, this involves cosine, tangent, and also sine. Okay, let me show you what I mean. When I see 2 sine cosine, that's ringing a bell. If I look at my double angle identities, the formula for 2 sine x is 2 sine cosine. So 2 sine cosine is the same thing as the sine of 2x. So the quickest thing to do would be to actually make that substitution. So 2 sine cosine is the same thing as the sine of 2x. So now I have the sine of 2x over the cosine of 2x. Well, this is going to be the easiest problem ever because we know that sine over cosine, that's tangent. So that's it. This equals the tangent of 2x. And then I'm just going to bring down my right-hand side, which I never touched. And that's it. We verified that identity. This probably would have worked out somehow or another if I had maybe substituted cosine 2x for one of these 3 identities. But I think you'll agree that this is by far the easiest way to do it. Problem number 14, we have cosine squared times 1 minus tangent squared. And somehow that's equal to cosine 2x. We are going to choose the left-hand side because that looks by far the most complex, and we will manipulate it and see what happens. One thing that's jumping out at me is 1 minus tangent squared. Is that one of our Pythagorean identities? Okay, no, it's 1 plus tangent squared, so never mind. Instead, I think I will simply do the distributive property. I'm going to take this cosine squared and go blam, blam, like that. So I'm going to have cosine squared x minus cosine squared tangent squared. Let's rewrite tangent in terms of sine and cosine. I have cosine squared x minus cosine squared x times sine squared over cosine squared. Interesting. I am noticing that I have cosine squared in the numerator and cosine squared in the denominator. Those are going to cancel each other out. So that will leave me with cosine squared x minus sine squared x. Isn't that the identity though? Let's check it out. Cosine squared minus sine squared. That is the identity for cosine of 2x. So it's a two-way street. Cosine squared minus sine squared is the same as cosine of 2x. So I can replace this with the cosine of 2x, which is the target. Last problem. The left-hand side looks like it is the most complex. So let's start with the left-hand side. Specifically, I'm seeing the double angle right here. Okay, here's my thought process. I have this binomial here, 1 minus cosine 2x. But on the right-hand side, there's no binomial. There's just a single term. That makes me feel like it would be nice if we could just cancel this 1 out. So I am going to look for a version that will end up canceling out this 1. So let's see what we have. Okay, so what if I did the 1 minus 2 sine squared? Let's make that substitution. First of all, I'm just going to leave everything else the same. So I have cosine squared x, and then I have this 1 minus. All right, whatever comes next, I'm going to go ahead and put it in parentheses because I'm going to have to distribute that negative sign. So let's see what happens if we do 1 minus 2 sine squared. So I'm going to have my 1 minus 2 sine squared x. If I distribute the negative sign, I'm going to get, so I have cosine squared over. Without the parentheses, this becomes 1 minus 1 plus 2 sine squared x. And this is what I was talking about. I wanted to try to cancel these 1's out so I would only have a single term. And that's what's happening right now. I'm getting 1 minus 1, so these are going to cancel each other out. So then I will have cosine squared x over 2 sine squared x. Well, that's very interesting because cosine over sine is cotangent, and that's one of the things that we are shooting for. So in fact, what if I separate this out? So I'm going to write my cosine over sine separately. So I've got my cosine squared x over sine squared x. As I separate that out, the rest of it is 1/2. It's almost like there's this invisible 1 right here. So I've got the 1/2 times cosine squared over sine squared. Obviously, that's the same as what I had before. But now I can plainly have 1/2 times cotangent squared. And then it's easy to see that this is the same as cotangent squared x over 2. And that, my friends, is the target. So cotangent squared over 2 equals cotangent squared x over 2.